All right, hello class, this is Ms. Riggins and we're back on page 135 discussing the area of regular polygons inscribed in circles. So let's go back to the notes on page 135, and we have a formula, and there's more than one way to represent the formula. The way the textbook does it and prefers to use it is the area of a regular polygon, which means all sides are congruent, is 1/2 A, which is the length of the apothem, which is the height of a central triangle, times the perimeter. Another way that we've done it in class is we found the area of one of the triangles of the regular polygon, and that's 1/2 S times A, and multiply it times N. And so both of these represent the exact same thing. So how you choose to use it is up to you. But what is important for both sets of both versions is you need to find the length of the apothem, which is the height of the central triangle, and you need to know the length of the side length of each polygon. And once you have that, and of course you need to know the number of sides in the polygon. And those are the three things that you need in order to find the area of a regular polygon. So we're going to go over two examples. They can be found on page 301 and 302 in your note-taking guide. You can follow along with me, or you can print these notes out and fill them in as we go along in the video. So here we have a problem, and here we have a coaster, and it's an octagon, and it has 3 centimeter sides, which means each side length is 3 centimeters. And it has a radius of 3.92 centimeters. Now, those of you who remember the formula for the area of a regular polygon know that the radius length is not part of the area of the regular polygon. But we are going to use that length in order to figure out the area of the regular polygon. So in order to do this, again, the book likes to use the formula 1/2 A times P, so to find the area of the polygon, and that's what we're going to do here. So the first thing they say is to find the perimeter of the polygon. Well, the perimeter of the polygon is pretty easy, because the perimeter of the polygon, since each side is 3 centimeters and it's an octagon, which means it has 8 sides, then the perimeter can be found by taking the 3 centimeter sides and multiplying it times 8. Well, that's another way in the original formula as saying N, and then this is S. So regardless, we have that the perimeter is 24 centimeters. So in order to finish out our formula, we have to find the apothem. And the apothem is next. And then that's it. So the apothem, though, is the height of the triangle. And as you can see here, they don't have a triangle drawn to represent the central triangle or any of the 8 central triangles. So what we're going to do is we're going to take the center R. We're going to take a point, one of the vertices of the polygon, P, and its corresponding and its adjacent vertex, Q, and we're going to make that triangle. So this is my central triangle that we talked about. And then A represents the length of the hypotheme. So this is what we're trying to find, which is this length. Now we already know from earlier that the side length of the regular polygon was 3 centimeters. So if I take a look at this isosceles triangle, which we know is isosceles because we said earlier in previous videos that this is an isosceles triangle since they're made up of the radii of the polygon. We said that here we can draw a perpendicular line, which is the apothem, and we've broken up this shape into a right triangle, which we have spent a lot of time finding unknown side lengths of a right triangle. So now, in order to figure out the apothem, we have to decide which strategy we want to use to find the unknown side length. Well, we know that this part of this triangle is 1.5 centimeters because it's half of the side length. And they told us in the problem that the radius is 3.92. So we have this side length. We know how long that side length is. So it makes sense that we can use Pythagorean Theorem. So what we're going to do is, just FYI, RS is the apothem, and the height of the triangle PQR. And RS bisects QP because it's isosceles. And to figure out QS, we know that's half of the side length of the entire polygon, so that's half of 3, so that's just filling that in. So let's take a look here. To find our S, we can use the Pythagorean Theorem. Since A is the unknown side length, that's a leg of the Pythagorean Theorem, we can fill this in by taking the radius squared, which is our hypotenuse of a right triangle, and subtracting it from the 1.5 squared. And when you do that, you get 13 point, oops, sorry. You get 13 square root of 13.1164, and you get approximately 3.62. So now all we have to do is figure out the area formula. So we have 1/2 A, which we found to be 3.622, times the perimeter, which we found to be 24, and we have approximately the area to be 43.5 square centimeters. So again, all we did was we used Pythagorean theorem to figure out the unknown value. Let's take a look at another example, and this is example 3. They want us to find the perimeter and area of the nonagon, and nonagon means it has 9 sides. So one of the things is they have only given us one side length, and that is the radius side length of our triangle. So in this case, the only thing that we know is that the radius is 5 units. We don't know the side length, and we don't know the length of the apothem. So this is going to be a little bit more challenging to find the area of the regular triangle. So in this case, but let's see what we do know. Since it is a nonagon, that means it has 9 sides. So to figure out the measure of the central angle, we take 360 divided by 9 because it's 9 sides. And that will give us this answer. And this answer is 40 degrees. Oops, sorry. And again. So I know that that length right here is 40 degrees. Well, why is that important? Well, we know that the apothem bisects this angle, so that means that the measure of the itty bitty angle, angle KLM, is going to be half of this 40 degrees. And so that means that measure of angle KLM is 20 degrees. So I like to draw the right triangle that we're working with, and that's what we have right down here. The right triangle that we're working with is this right triangle, and where this angle is 20 degrees, and they gave us that the radius was 5, and we have to figure out 2 pieces of information to find the area. We have to figure out the apothem, and we have to figure out the side length. So what do we do when we need to figure out a side length when we only have one side length and an angle measurement? We either use special right triangles or we use trigonometry. In this case, we're going to use trigonometry because we have an angle that measures 20 degrees. So if you remember, the sine of this 20 degree angle is the opposite over the hypotenuse. Well, our opposite leg is MK, and our hypotenuse is 5. So when I plug 5 times sine of 20 in the calculator, I will get the length of MK. And to figure out the apothem, that's the adjacent side of the right triangle, and we can use cosine because cosine of 20 degrees is equal to adjacent side LM over the hypotenuse. So to find LM, we multiply 5 times the cosine of 20 degrees, and that will give us our LM. So now we're almost done because now we have a way of calculating at least 1/2 of our side length, and we have a way of calculating our apothem. So since MK represents 1/2 of the side length, then 2 times MK will represent our, oops, yet again, sorry. 2 times MK will represent this length of one side of the polygon, and that's 10 times sine of 20. And then to figure out the apothem, we found that was 5 times the cosine of 20. So now in order to find the perimeter, we multiply 9, since it's a nonagon, times the side length, which we found to be equal to 10 times the sine of 20. And when we finally put that in the calculator, we end up with around 30.8 units. And then when we use that in our formula, 1/2 A, which we saw was 5 cosine 20 times the side length will give us the area of the entire polygon.